Hello, and welcome to Summarize Science, where we break down complex research into simple terms. Imagine you're tracking something important over time, like daily stock prices or a patient's heart rate, but suddenly, some of the data goes missing. This creates gaps or blind spots, and the process of intelligently filling in this missing information is called imputation. It's a huge challenge because a bad guess can lead to wrong conclusions. This paper explores a cutting-edge AI method to solve this very problem. The researchers focus on a powerful new tool called a diffusion transformer. You can think of this as a combination of two superstar AI technologies. Diffusion models are the magic behind AI image generators, brilliant at creating realistic data from noise. Transformers are the engines behind language models like ChatGPT, which are masters of understanding context and sequences. By combining them, the hope is to create an AI that can understand the story of the data and fill in the missing chapters. But the researchers wanted to go deeper and answer two fundamental questions. How well can these models really perform, and how does the specific pattern of missing data affect their accuracy? And what they found is fascinating. It turns out that it's not just about how many data points are missing, but where they are missing from. Take a look at this chart from the paper. Each line represents a sequence of data, and the colored bars show different patterns of missing values. Pattern 1, a long consecutive block of missing data, is extremely difficult for the AI to fill in. However, pattern 4, which has the exact same number of missing points, but scattered randomly, is much easier. This key insight shows that a concentrated loss of information is a fundamentally harder problem than a distributed one. This discovery led the researchers to a brilliant idea for a new training method. They realized that if you only train an AI on easy problems, like randomly missing data, it will perform poorly when it encounters a hard, real-world problem, like a sensor being offline for an entire day. So, they proposed a mixed masking training strategy. This involves showing the AI a diverse range of missing data patterns during its training phase, from easy and random to difficult and clustered. The results were dramatic. The model trained with this mixed strategy significantly outperformed the one trained on easy patterns alone, especially when tackling the hardest test cases. They then confirmed these findings on more complex and noisy data that better simulates messy, real-world conditions. Even in these tougher scenarios, the diffusion transformer, especially when trained with the mixed masking strategy, proved to be more accurate than other leading methods. So let's recap the important takeaways. First, diffusion transformers are a highly effective tool for filling in missing time series data. Second, the pattern of missing data is critically important. A single large gap is much harder to solve than many small ones. And third, the proposed mixed masking training strategy makes the AI much more robust and adaptable. This work is a big step forward because it not only gives us a better tool, but also a deeper understanding of why it works. In the future, this could lead to more reliable financial forecasting, more accurate climate models, and better patient monitoring systems, all by intelligently and confidently filling in the gaps in our data.